In the last class we had seen only, I think, two problems, okay, on the radius of curvature. Okay, so I thought I should take few more problems on this. So let me solve a few more problems, and then we can go on the concept of what centrifugal force. So guys, let me write down the problem number 3. Okay, so problem number 3, guys. Okay, so the question says like this, guys, that a particle is projected horizontally from the top of a tower with velocity v naught. Okay, so guys, this is projected with velocity v naught. Okay, and then it is saying if v be the velocity at any instant. So of course guys, it will go like this, and let's say at any moment the velocity here is how much, v. Okay, and then it is saying be let if v be the velocity at any instant, then the radius of curvature of the path of the particle at that instant is directly proportional to, okay, is directly proportional to. Options are guys v cube, v square, c is v, and d is 1 by v. Okay, so it's of course this problem is also guys what a easy problem. Okay, let's see how we can solve this problem. So guys, if I let me change the color, guys. Okay, so guys, if you see, the thing is here the g would be acting in this direction. This is your velocity v. Now we can do this problem again, guys, what with the help of vector form also and without vector also. Okay, so I am going to use both the methods. I'm going to show you that both the methods can be used here. Okay, and you can get the same result with the both the ways. Okay, first let me solve it, guys, what without using any vector calculation. Okay, so guys, if you see, let's say this will be, guys, of course this component will be what, v naught, we know that. And guys, this is, let's say, this is what, guys, this will be your velocity vy component. Okay, and this is of course, guys, what, vx component. So if this angle is, 1 minute, guys. Okay, if this angle is alpha, okay, this angle is alpha, so guys, we can say this is, let's say, the uh, a centripetal, which will be what, perpendicular to v. So guys, if you see, if this is alpha, this will be what, pi by 2 minus alpha. So this will be what, guys, of course alpha. Okay, so what we can say, if this angle is alpha, this will be what, guys, g cos alpha. I hope you're getting my point. This will be what, guys, g cos alpha. So here also, guys, the same way that we have done in the previous question, similar way, guys, here also what we can say, that rc will be nothing but what, v square divided by g cos alpha. Okay, and how do we get, guys, cos alpha? For cos alpha, if you see this vector diagram, okay, that I am making, guys, if you see, this is what, this is v naught, and of course this is your vy, and this is what, guys, vx, and this is alpha that we are calling. So guys, what we can say, we can say that cos alpha here is nothing but what, vx divided by v, which is, guys, nothing but what, v naught divided by v. So guys, here rc will be what, v square divided by g into v naught by v. So we will go in the numerator, guys. So rc will become v cube divided by g v naught. So that would be the answer. So guys, we can say the radius of curvature will be directly proportional to what, v cube. Okay, it will be directly proportional to what, guys, v cube. I hope this is settled, guys. Okay, it's also a simple problem only. Okay, but yes, of course, it can build your concepts at a certain level. Now guys, let me take one more problem, and then I think that would be enough in terms of what, understanding the idea of radius of curvature. Okay, so if you see, guys, the problem number problem number 4. Okay, so here, uh, guys, the question says like this, that the figure shows the velocity and acceleration of a point like body at the initial moment of its motion. Okay, So guys, the figure that has been shown here, I am just making it for you. Okay, so the figure shows like this guys. Okay, just see. So this is what guys, this is your velocity v naught. It is given right now is how much, 8 meter per second, and as your acceleration is given here, this a is 2 meter per second square. This is the thing that has been given guys. Now it is saying the minimum is, after that it says the acceleration vector of the body remains constant. So guys, this would be the direction of what you can say acceleration vector throughout the time. Okay, this is not going to change. Okay, this is not going to change. This is your acceleration vector direction, and the magnitude is also going to be what guys, constant. So the minimum radius of curvature of the trajectory of the body guys, so they are asking that whatever the particle will take as a path, of that path at any certain moment, what would be the minimum radius of curvature that is possible. Okay, so guys, this question is actually also indirectly associated to the motion of what, projectile motion. Let's try to understand. If any particle is projected with certain velocity, if any particle guys is projected with a certain velocity, and there is a constant acceleration is acting on the body, we know that guys it is going to follow a projectile motion. Like guys, if you see the example, it is going to follow a parabolic path. Like guys, if you see, if I make this thing for you here guys, if you see, let's say a particle which is have been projected. Okay, if you see here guys, gravity is continuously acting downward, and it has been projected with a certain velocity, let's say v naught. So guys, here if you see, the gravity is continuously acting on this in this direction, and because of this gravity guys, the body or the particle is getting some downward velocity in the downward direction. It is getting what, the downward movement, and of course because of the horizontal component, it is moving in the horizontal direction. So this kind of a curve it is going to take. Okay, this kind of a guys, what curve it is going to take. I hope you're getting my point. So guys, we know that in the case of projectile motion, if you talk about, okay, in the case of projectile motion, if you talk about, we know that guys, the maximum radius of curvature is possible actually guys, what, sorry, the minimum radius of curvature that is possible is guys what, at the just let me is move this thing so that I can show you guys, it is only possible at what, at the maximum height. Okay, why is it so guys? See, the RC, the RC is actually guys what, it depends on V square divided by AC guys. Of course at the maximum height, this will be what guys, it is because constant, and it will be what, maximum there, because V and G will be what, perpendicular. So guys, here it will be what, maximum as a magnitude, the AC, and of course guys, velocity will be what, minimum at this moment. Okay, okay, so guys, of course if you see, this is maximum and this is what, minimum. So of course guys, automatically we can say the maximum the minimum radius of curvature that is possible during the journey of this particle would be what guys, when the particle is at what, at its maximum height. So using this idea guys, what we can say, that here if I make the, this is what guys, gravity, and this is your AC, and this will be what guys, this will be your v naught cos theta, where guys theta is this angle. So guys, if you see, they have given here right now, this angle was given guys 150, I guess so. Yes, yes guys, this angle is given to you what, 150 degree. So guys, what we can say, that if you see guys, here also this is 150 degree. So guys, if you see, this angle is what, 90. So this angle can be taken as what guys, as 60 degree. So what we can say, that here theta is how much guys, 60 degree. So using this idea, what I can call guys, that this will be v naught into cos 60 whole square divided by g. So guys, v naught is given I think 8, so 8 into 1 by 2 whole square divided by g guys, sorry, here g is what guys, the acceleration that of the particle, and that is what guys, 2. So here we will put, guys, what, 2, because that is the acceleration that is acting on the particle continuously in a certain direction with a constant magnitude, guys. So this will be what our G here for right now. So guys, if we solve this, I think we will get the answer. This will be, guys, what, 4. So square of 4 is what, 16, and divide by 2, that is what, guys, 8 meter. Okay, so guys, the minimum radius of curvature possible here is what, guys, 8 meter. Okay, so that's a very simple question that not, I would say that it's a simple question, guys. It is very tricky problem actually, but yes, conceptually it is a very rich problem, okay, in terms of radius of curvature as a concept. Okay, so I hope you understood this problem also, guys. Now uh, we will see in the next lecture the centrifugal force and the illustrations on that. Okay, thank you.